Okay guys, welcome back to my channel. So today we're gonna explain for the next chapter, which is we want to discuss about solution aqueous reaction for part 2 for still to prepare our ACS exam. Okay, now let's move on to a first question or first study question. And then I need to writing down first for the region. I mean for the structure for this question. Okay, so this is the region one. Okay, region one. And then what's the next one is C C H H, and then this is the region 2. Region 2. And then the last one is for C H H C O O H. And then the next one is for this part is region 3. Okay, region 3. Okay, where is the hydrophilic attracted to water region of the molecules? Okay, so how to solve this problem? So first, we need to know. Okay, okay, we need to know that the region 1 is hydrocarbon. Okay, hydrocarbon chain of 2 carbon and their hydrogen. Okay, region 2, we have a double bond over here, right? We have a double bond, right? And then another one for region 3 is the group of carboxylic acid. Okay, carboxylic acid. Okay, carboxylic acid. Nah, now let's to break down the concept. Okay, to identify which one that hydrophilic, we look for parts of the molecule. Okay, we look for parts of the molecule that can form, okay, can form hydrogen bond. Hydrogen bonds, okay, with water. The next step is have electronegativity. Have electronegativity like oxygen, and or nitrogen. Okay, or nitrogen. Okay, and then polar and charge. Okay, this is the concept. Okay, the hydrophilic region. Philic region. So now let's take a look at one by one. For region 1, you get the 2 carbon surrounded only by hydrogen atom. This is the classic like hydrocarbon chain. Okay, non-polar and hydrophobic. Okay, this one is non-polar and hydrophobic. Non-polar and hydrophobic. Okay, we need to pause first. Okay, for a while. All right, so we continue for a while, probably like 10 till 20 minutes. So let's uh finish it first for the first question. Okay, so like I mentioned, hydrophilic reagent should have like it can form hydrogen bond with water, and then have electronegativity like O or N. Okay, and then polar and charge. Okay, polar and charge. Okay, now let's take a look at one by one. Okay, for the region one is non-polar and then hydrophobic, right? And then the region 2 is this region is double bond. Again, we are saying only C and H, okay? Like region 1, which is non-polar and hydrophobic as well. So the answer is region 3. Okay, why? Why? Because it has two oxygen. It has two oxygen. Okay? One double bond and one is hydroxyl. Okay? So in this case, have electronegativity such as O or N. Alright? And then, is that polar? Yes, we can say is that polar. Okay? That one is polar. Okay? And then can form hydrogen bond with water. Okay? If you're looking at COOH. Okay? In this case, C plus, this one is minus, right? If you see over here, guys, so this O could be bond with OH over here. It could be bond with the, I mean, yeah, H O. So this is minus, this is plus, this is minus. Okay, so it's still possible to bond with water. So in this case, this is the strongly hydrophilic. Okay, hydrophilic. Okay, so just a quick tip, guys, that if the question is about hydrophilic, okay, hydrophilic, scan like for O and which one that has O or N atoms. Okay, scan this part. Okay, especially like OH or COOH or NH2 groups. So this is the quick tip to get a hydrophilic part. Okay, to get hydrophilic part, always looking at which one that has electronegativity, like such as O or N, COOH, OH, or NH2. All right, so let's move on for the next question. Let's move on for the next question. Okay, the next question is talking about, we are asked about what? Which molecule is most soluble in water? Okay, which molecules that most soluble in water? Which one that most soluble in water? Okay, how to answer this question is pretty easy. Okay, like I mentioned, the concept here is what makes a molecule water soluble. Okay, water is polar. Okay, we know that water is polar. Okay, water is polar, and then it has hydrogen bond. Okay, hydrogen bond. Okay, so we need to find out which one that polar. Okay, which one that polar as well, to dissolve well in water. Okay, and then molecule can form hydrogen bond as well. So we need to find out the same thing. Okay, like OH or an H2. Okay, because it's like especially water loving. And then we need to see like once more, like for non-polar molecule. Okay, for non-polar molecule, non-polar. Usually like long hydrocarbon. Okay, long hydrocarbon. Generally hydrophilic. Hydrophobic, sorry. Hydrophobic and poorly soluble. All right. So let's take a look at for option D and B. See, those like has very long chain over here, like long chain hydrocarbon, which is we can eliminate this part. All right. And then how about the option B? The option B, this is ether. Okay, this is ether. It has oxygen, then can react for it the hydrogen, but it lacks like OH group, so no donating. In somewhat soluble, but still mostly non-polar. Okay, ether, so look most likely like non-polar. All right. So now let's move on for option A and C. Okay, because you see in option B and D it has like longer chain, we can eliminate those one. Okay, just remember when the molecule has long hydrocarbon chains, it's more likely insoluble, like poorly soluble in water. So now let's take a look at option A and C. Which one that most soluble? Okay, which one that the most soluble? Okay, let's take a look at for A option. This is ketone. Okay, ketone. And it has polar over here, okay? CO, okay? It has polar molecule. So it's soluble, right? Because water is polar, and then it has also hydrogen bonding. However, okay, however, it cannot it cannot hydrogen bond directly with water, so it's like moderately soluble, moderately soluble. So in this case, the option C is the best answer. Why? Because see, we have polar groups here. Okay, we have the polar group CO. Okay, we fulfill the requirement that we have to have the polar molecule to be to be soluble in water. Okay, how about hydrogen bond? Okay, it has hydrogen bond over here, OH. Okay, it has hydrogen bond. So if we want to break it down, it will be CO OH. Okay, and then OH group can that that can hydrogen bond as donor or acceptor. Okay, so very hydrophilic over here. So yeah, when we are looking at which one that like the water for water solubility, always look at OH and then COOH and then NH2. Still the same concept as the previous question. Okay, still same concept with the same uh with the previous question. Okay, the more polar the better it mixes with water. Okay, just looking at which one that containing OH, COOH, and then NH2. Okay, so because of the option A doesn't contain any kind of hydrogen bonding, so it reduces the solubility of this compound in water. Okay, yeah, so something like that. So now remember, SOH group can hydrogen bond both as donor or acceptor with water. Okay, can bond with the OH. Okay, so it has like so the prob I just want to like I just want to draw how it looks like when it bond with water, CO, and then it will bonding with water, kind of like this one. Okay, it will bonding such as this way. Okay, with this part. All right, and then it has O over here, right? And then it has H again over here, and then it also can be donor or acceptor. Okay, and then in this case this one also can be uh donor or acceptor. See, in this case H, okay, it has hydrogen bonding, over here again, and then we have another one, right? So when we are looking at which one that the most soluble, like solubility in water, just remember the concept of look for OH, COOH, and then NH2. Just looking at this group, as this is the same thing for the previous question. Okay, for the previous question. Okay, now I need to uh, take a rest for a while, or pray, so we can continue later on. Okay, I don't want to let's yes, we need to take a break first, and then we can continue after that. Okay. check. Okay. Now we continue our discussion for the next question. A solution of natrium chloride or sodium chloride in water has concentration of 20.5% by mass. What is the molar concentration of the solution? Okay, so the question is, what is the molar concentration of the solution? So it has concentration around 20.5% by mass, and then the molar mass itself is like around 58.44. This is the mr. So what is the molar concentration of the solution? Okay, so the total concentration is 20.5, so 100 minus 20.5. So the rest of solution is 79.5%. So if we assume this one 70.9, what is the molar concentration of the solution? So what is the molar concentration? This is the mass. Is 0 point gram per ml. 79.5 divided by 58.44. So has concentration 20%. What is the molar concentration of the solution? Okay, so you can see the percent by mass. Percent by mass. So this is the theoretical and mass of one component. The total is 100 theoretical. This percent or the total, and then 1 total, and this one is one component. Okay, and it should be same mass solid, mass solution, mass solid per mass solution. Molar concentration, it should be mole solid, mole solvent in kilogram. Yes, 79.5, right? So this one is water, and then the other one is gram NaCl, right? So the total is 100. The question is, what is the molar concentration? So 20.5. So the answer. Okay, so in kilogram, this is gram times 58. Still. Mm-mm. Hmm. Okay, so let's break it down one by one. So 20.5% NaCl. So it's same as 20.5 gram NaCl in 100 gram of solution. And then the molar mass is 58.44 gram per mole. And then the equation of molality is mole of solute, so mole of solute per kilogram of solvent. Okay, solvent, not solution, not solution. So first step is assume we have like 100 gram of solution. 100 grams of solution. This is first step. So we need to convert. We have water. Okay, we have water. So we need to find out the gram of. This is the total is 100, right? And then this is NaCl, and water is 79.5 gram water. Okay, so we need to convert it into kilogram. So divide it by 1000, and then it will be 0.0795 kilogram. Okay, so just remember mole solute per kilogram of solvent. Okay, mole of solute. Okay, mole of solute per kilogram of solvent. Okay, and then now we need to convert to get we already got the solvent, right? We already got the solvent. And then what's the mole of solute? Okay, we need to determine this one. So mole is 20.5 gram per 58.44 gram per mole. So it will be 0.359. Now we just plug into molality formula. So M 0.351 divided by 0.0795. It will give us 4.41 mole per kg. Okay, mole per kg. Okay, just quick tip that molality use mass of solvent in kilogram. Molality use mass of solvent in kg. Okay. All right. So just remember this equation. M molality, molar concentration. Molar concentration is a mole of solute divided by kilogram of solution, solvent, not solution. Okay, solvent. Okay, molality. Okay, molality is mole. Molality is mole per liter. Okay, per kg of solvent. Okay, kg of solvent. All right, just remember this one. M molality, mole per solvent. All right, we got it. So let's move on to the next question for the fraction. Okay, we have question: what is the mole fraction of water to 100 gram of 89% by mass ethanol? Okay, we need to determine the mole fraction of water in 200 gram. okay, in 200 gram. So how to get this one is, the first step is we have molar mass of ethanol, mr is 46 gram per mole, okay, and then we know the water is 18, okay, gram per mole, right? Okay, so assume we have, the first step is assume we have 200 gram of solution. Okay, so we know that we have like 89%, okay, of 200, so it will be 178 gram of ethanol. And then another one is like 100 minus 89, it will be 11, okay. So for the rest one, okay, the remaining one is like 11 per 100 times 200, okay, so it will be 22 gram of water. So assume we have 200 gram of solution, so 178 is ethanol, 20 gram is water, okay. Now let's convert one by one to moles, okay. 178 divided by 46, it will be 3.87 mole. How about this one is 22 divided by 18, so it will be 1.22. So the question is, what is the mole fraction? What is the mole fraction? It's pretty easy if we already got this one. Just adding both, okay? So we have x1 plus x2, x total. Okay? For the x total is 3x 3.x7 plus 1.22. So it will be 5.09. Okay? So now what's the fraction of this one? Just use the formula 1.22 divided by 5.09. Okay? So we have a fraction of at the end. So it will be 0.239. So the answer will be B. Okay, just remember, mole fraction is mole of one component divided by total. Just remember this equation, and then we can trace back to determine one by one the equation. I mean the answer. Now before, okay, we have still like some question out before we are going break. Before we are going to take a break. Okay, now let's take a look at this one. A mixture 100 gram and 200 gram is stirred at 60 degrees Celsius until no more of the salt dissolve. The resulting solution is poured off into spirit beaker, okay, leaving the undissolved solid behind. The solution is now cooled to 20 degrees Celsius. What mass of crystallized from the solution during the cooling? This is the data of that one. Okay, so just quick summary of the question. We start with the 100 gram, okay, K2CR2O7 and 200 gram water, and stir till 60 degrees Celsius, and then saturate it, okay, till saturated, and then cooling down to 20 degrees Celsius. And then the question is, how much salt crystallize out, okay. So now we can use the solubility graph over here. See the solubility graph over here. Check the solubility first. Okay, the first step is check solubility. This is the gram per 100 gram. Okay, so you will see at 60 is around 40, right? Around 40. Okay, for 60 degrees Celsius, it's around 40. Okay, 60 degree is around 40 per 100. Okay, and then at 20, it might be around 10. The question is, what mass of crystallized from the solution during cooling? Okay, so now we have information here that we have 200 gram. Okay, we scale those values. Okay, we can scale this value to twice because we have 200, right? In this case is 100, so it will be 80, and then it will be 20. Okay, now just looking at the answer over here is pretty simple. Like, what is during the cooling? So from 60 to 20, so it's around like 660. So the answer will be D. Okay, the answer will be D, just by looking at the diagram. Okay, just by looking at the diagram. All right, now let's move on to another question. Carbonate beverage have fizz because of gas dissolved in the solution. What increases the concentration of gas in solution? So this is the critical question, like the theoretical question. However, we need to understand some concept first before uh, answering this question. For the first concept, we need to understand about the solubility, solubility of gases. Number two, we need to understand the properties of concentration. Okay, so let's take a look at the answer of this question. So carbonate beverage have a fizz because gas dissolve. Okay, just we need to know the concept of gas. Okay, when the temperature increase, okay, the solubility, okay, the temperature increase, the solubility decrease. Okay, if the pressure increase, it increasing solubility. Like the soda can, right? If we increase the pressure, it will increase the solubility. It will like boom. Okay, if we increasing the temperature, the solubility will be decreasing. Okay, according to Henry laws, okay, the solubility of gas liquid is directly proportional to the pressure of the gas and inversely related to temperature. So if we cool the liquid, gas solubility increase. That's why warm soda goes flat faster. The gas escape more easily. Okay, so we cool the liquid, gas solubility increases. Okay, so let's analyze for for the answer. Okay. So when what increases the concentration of carbonate beverage have fizz because gas dissolve in the solution. What increase over here? Okay, cooling the solution. Okay, because a cooling solution. So which mean the temperature is decreasing, right? The temperature is decreasing. So cooling solution, it will be lower temperature, and then gas stay dissolve. How about B? Heating the solution, it will make gas escape. Escape. So it will be decreasing the solubility. How about the increasing the volume? The dilutes this dilute everything doesn't necessarily increase the gas concentration, right? Decreasing the volume still doesn't address the solubility. So the answer will be A. Just remember this concept of the solubility of gas. Okay? And remember to keep your soda fizzy longer. Keep it cold. Okay, soda to fizzy longer. Keep it cold. Keep it cold. Okay? Gas dissolve better in cooler liquids. Okay, keep it cold. Okay, cooling the solution. What increases the concentration of gas in solution? So to increase the solubility of gas, we need to cooling the solution, or we need to increase the pressure. Okay, the pressure. So now let's take a look at another question for calculation stuff. Okay? So for the first question, we know that we have like 100 gram of unknown was dissolved in 1 kilo kg. The freezing point lower by 6.36. What is the identity of this unknown compound? Kf is 1.86. Okay, so now we need to determine the freezing point formula. The formula used here is like delta Tf. Okay, I Kf m. Okay, so this one is Van Hoff factor. Okay, Van Hoff factor. M is molality. So moles solute divided by kg solvent. So let's put it over here to get the molality. So the question is the identity. We need to get the molality it's first. Okay, to get the m, we need to using the delta Tf, I and Kf. The delta Tf, okay, now for the second step, we know that uh an ACl will be an A plus and Cl minus. So it has two particles, which is I is 2. Okay, so now M delta Tf, okay, 6.36, 2, and then how about the 1.86? This is Kf. So M is 1.71 mole per kg. So now let's take a look at this one, the compound. Okay, so we have only for molar mass, we can calculate like 100 gram divided by this one, 1.71 mole per kg. Okay, mole per kg or mole. Okay, so it will give us like 58.5 gram per mole. So might be the answer will be D. Now, second question, which 0 point molar equation will have the lowest freezing point? Just just concept again. Check the concept. Delta TF will be IKF and then M. Okay, just remember this equation. So now all have the same molality and solvent. So we just compare I and I. We just need to compare I. Because we have the same amount of molal. Okay, we have same amount of molal. Okay, we have same amount of molal. And then KF also lowest freezing point. Okay, we have the same KF as well, so we can like ignore for KF. So now we need to identify for I. Okay, let's take a look at for A. For A, it will be Al3 plus and then NO3 minus, kind of like this, right? So I is 4. So, and then how about this one? Ca2 plus and then 2Cl minus. So I will be 3. How about this one? This one, it will be C2. This is because this one is electrolyte. Okay, this is non-electrolyte, so I will be just 1, and then this one is 2. Okay, so you know the we know the more ions, it will be giving us like more freezing point. Freezing point. So in this case, option A, because it has 4, it will be much more bigger or much more like it has lowest freezing point. Okay, so that's all for the study question. We will continue for the next part in in